So today on our talk about complex numbers, we're going to talk about i's. And by I don't mean myself. I actually mean a certain number. So what is I? I is technically the square root of -1. We learned previously in our real number system that we can't take the square root of a negative number. So we invented a new system or a new extension called complex numbers. We created this imaginary number called I, which is equal to the square root of -1. I is short for the term imaginary number. So what exactly is I squared? You would think we'd have the square root of -1 times the square root of -1, which I can shorten as the square root of -1 times -1, which we would think is equal to the square root of 1, which is equal to 1. But why would we invent a number for something we already have? That's not right. So we already know that the square root of 1 is 1. So let's think about this a little bit differently. The square root of 4, you would all tell me, is 2. Well, that's the same thing as saying that the square root of 2 times the square root of 2 is equal to 2. So using that logic, let's think about I squared. So the square root of -1 times the square root of -1 is -1, which is I squared. So I squared is actually -1. So what about I to the third power? So we learned from our exponent rules that I to the third power can be equal to I squared times I because we add our exponents 2 plus our exponent here 1. So we learned that I squared is actually -1 and we know that I is just I. So -1 times I is actually -I. So I to the third is -I. What about I to the fourth? Again, by our exponent properties, we know that I to the fourth equals I to the third times I. We just learned that I to the third is -I times I is equal to -I squared. Well, we learned before that I squared is -1. So the negative or opposite of -1 is equal to 1. So I to the fourth is actually equal to 1 again. We can also think about it this way. I to the fourth can also be written as I squared times I squared. And we learned that I squared is -1. So -1 times -1 is equal to +1, and I to the fourth is equal to +1. So let's continue talking about this from a broader sense. Any power to the 0, so I to the 0 is always equal to 1. We've learned that rule with our exponent rules. We just talked about how I to the first is equal to I, or the square root of -1. I squared is equal to -1. I to the third power is equal to -I. And I to the fourth power is equal to 1. Well, continuing with the pattern you see I to the fifth is equal to I to the sixth is equal to -1, I to the seventh is equal to -I, and so on. You can almost go in a circle if I make my x-axis my real numbers and my y-axis my imaginary numbers. We can start at I to the 0 is equal to 1, I to the first, I to the second, I to the third, I to the fourth, I to the fifth, I to the sixth, I to the seventh, I to the eighth, ninth, 10th, and 11th. And you can see the pattern goes in a circle, and I have 4 steps every time. Well, instead of having to do this pattern for our higher numbers, why don't we just think about the process? Since we're making 4 steps, why don't we just divide our exponent number by 4 to see how many steps we actually have to take beyond going a full circle? So if I divide by 4 with a 0, I get a remainder of 0, a remainder of 1, and a remainder of 2 when I squared, a remainder of 3 when I is to the third power. If I divide by 4 again with my higher powers, I get a pattern of a remainder of 0, a remainder of 1, a remainder of 2, a remainder of 3. And you can see that a remainder of 0 always equals I to the 0th power. A remainder of 1 is equal to I to the first power. A remainder of 2 is equal to I to the second. And a remainder of 3 is equal to I to the third. So you can see in our wheel, we can actually correspond if we divide our values by 4, the remainder value will tell us what that I is equivalent to. So you can see here, for I to the 464, 464 divided by 4 has a remainder of 0. So it's equal to I to the 0th power, and it's equal to 1. I to the 23rd, if I divide that by 4, I get a remainder of 3. So that is equivalent to I to the third power, or -I. I to the 3002 is equal to I squared because the remainder of 3002 is 2. So we have -1. So we can continue in a pattern. Now, a French mathematician named de Moivre would tell you guys to hurry up and learn binomial theorem and trig identity properties, which you would get in pre-calculus, and the unit circle, which you'll get in the end of accelerated geometry, and complex roots, so he can teach you his theorem and a shortcut and a way to find complex roots. But keep in mind that he was a poor math tutor his whole life who conned people through chess games to get extra money. And his best friends were very famous, Isaac Newton and Halley, who found the Halley's Comet. So he's just impatient and wants you guys to know who he is too. So if you guys have any more questions about complex numbers, let me know, and I'll be glad to give a little video and let you know what's going on.